So first thing we're going to do here is we're going to connect the 2 points with a straight line. And I'm going to go ahead and draw it a little longer. And what we have there is called a secant line. Now, here's what's interesting, or what's nice about this relationship. The slope of the secant line, is the average rate of change. So, in part A, we found that the average rate of change between 0.4 and 0.8 was 12.8 feet per second. So let's make a mark of that. 0.4 to 0.8. We found out that that was 12.8 feet per second. So what that means, between 0.4 and 0.8 seconds, the ball was traveling on average 12.8 feet per second. Now, if we look at some of the intervals that we did on this, we did the average rate of change in part A. We did between 0.8 and 1.2. So we could do a secant line there. And then we started doing points closer. We did closer and closer to 0.8. We started using values from both sides closer and closer to 0.8. So if we start drawing those lines in, we're getting closer and closer to the tangent line, which would only touch at 0.8. So what we're doing is we're using those average rates of change to see roughly what our rate of change would be at 0.8, which is called an instantaneous rate of change.